This is the UnShaw Podcast, a podcast about atheism, religion, and everything in between.
Sure is, Donald. Welcome to a brand spanking new series of the UnShaw Podcast. God, I've missed you all. This season, I've swapped my recording date from Liverpool to the unfairly misunderstood Wiltshire town of Swindon. And what better place to host the usual whirlwind of minds and opinions? Expect the same eclectic blend with contributions from atheists, imams, academics, priests, doctors, evolutionists, nurses, ex-prisoners, former junkies, scientists, lawyers, gypsies, tramps and thieves. As always, we'll be tackling the big questions and probably failing to answer them. What happens when we die? Where did the universe come from? Is there a God? Did we get here by divine design? Or are we just really smart apes? And for our first episode, we're kicking things off by heading straight to one of the intellectual powerhouses of the world, Oxford University. I'll be sitting down with none other than the Professor of Zoology, Tim Coulson. He's just penned a new book, The Universal History of Us, which dives into the latest academic takes on life's ultimate mysteries. So grab your pipe, put a couple of pinches of your finest shag in it, and listen as we try to answer the mysteries of the universe. Good morning, Tim. Thanks for joining me.
Thank you very much for having me.
So, we are here ostensibly to talk about your new book, which was published recently. And I've not had the opportunity to read all of the book, but I have read parts of it. And would you agree with my summary of the book in that it is a book for the educated layman about how we as a human species came about, right from the very beginning up until the present day? Is that right?
I think that's fair. I describe it as a popular science book on what science can tell us about why you and I exist.
I mean, the best place to start really is the beginning. So, the Big Bang. I've heard people refer to the Big Bang as being a little bit of a misnomer. I remember speaking to someone who said that the Big Bloom might be more of an accurate description. Tell us what happened at the Big Bang.
Okay, so what scientists have been able, and astronomers and physicists have been able to collect is quite a lot of information from the current universe, including observations that stars, the majority of stars and majority of galaxies in the universe are moving away from us. And the further away they are from us, the faster they are receding. So this tells us that at the moment the universe is expanding, it's getting bigger, and that rate of expansion is increasing. And if you were to play the clock backwards and to sort of say, okay, well, what happens if we were to reverse time from where we are now? What would happen? And when you play that clock backwards, you come to the conclusion that the universe must have started as at a very tiny single point, what scientists call the singularity. And that singularity came into being about 13.77 billion years ago as an extremely small, extraordinarily hot, tiny pinprick, smaller than the smallest fundamental particles that we see today. And quite why that pinprick of extreme energy arose, we have theories about, but we've not been able to test that as scientists. But once it began, once it had formed, it started expanding, and we are a consequence of that. So 13.8 billion years ago, or 13.77 billion years ago, the Big Bang happened as that singularity. It was an extraordinary small point of energy, and the entire universe that we can see part of now exists as a consequence of what's happened since that Big Bang. And scientists made some predictions about what we would expect to see in terms of various types of radiation scattered across the night sky, including something called the cosmic microwave background. And when they looked for it, it was there as the theories predicted. So evidence for the Big Bang is really quite compelling, but it was a very tiny, so big wouldn't be the right word. It was very, very tiny. It was extraordinarily hot, and the entire universe has grown from that.
Okay, and I've heard people say what caused the Big Bang and ask questions like, what was there before the Big Bang? What was there prior to that?
Well, so the answer to that question is currently beyond the scope of us and of science. And the reason for that is we are part of the universe. So we are in the universe and we can't leave the universe. We don't know where the universe's edge is. We can't see the edge of the universe, even if it has one. And that means we can't leave the universe to see what's outside of it. So whether there is anything outside of it, whether we would be able to see other universes is, people talk about the multiverse. We don't really know. However, one of the assumptions that scientists have made, and some mathematicians have done this research, say that whatever there was before our universe existed may well have been unstable, and that our universe and possibly other universes appeared from that instability. But that's just a theory, and we have no proof of that, and that comes from various sort of mathematical models of where the universe may have come from. But currently we can't test those. So anything I would say about what existed before the universe and where it came from would be pure speculation and isn't founded in science. One of the things that science can't tell us at the moment is why there is something rather than nothing. But once that universe got going, we've got quite a good understanding of what had to happen for you and I to be here today having this conversation.
So what you seem to be saying is that we don't know what happened prior to the Big Bang, and potentially we may never know.
At the moment, we don't know. I mean, it's always risky to never say never, but at the moment, we have no way of being able to work out what existed before our universe and where the universe came from. That's correct. We just have some theories.
So all of the matter in the universe, and you might have to excuse my scientific ignorance on this one, all the matter in the universe has existed since the Big Bang. Is that right?
So just after the Big Bang, the Big Bang was, when the universe began, it was an extraordinarily, as I said before, extraordinarily hot piece of energy. And some of that energy was converted to matter and some of it into antimatter in the first fractions of a second of the universe. And so the matter was in the form of quarks and electrons, and antimatter in the form of antiquarks and positrons. So when antimatter and matter come together, it annihilates something else, creating energy. And for reasons, again, that we're not entirely sure about, but again, there are some hypotheses and some tests being done on this, because we can create antimatter. There was a little bit more matter than there was antimatter earlier on in the universe. And that meant there was a little bit of matter left over after antimatter and matter annihilated one another. So what we're left with, the stuff that you and I are made from, the stuff that the Earth is made from, the Sun is made from, all the matter we can see in the universe formed as quarks and electrons very, very early in the universe's history. And then over time, when the universe was still quite young, the quarks were able to combine to form protons and neutrons. And then when the universe was close to about 300,000 years old, the protons and neutrons combined with electrons to form the first atoms. And those atoms were primarily hydrogen and helium.
Moving on, your book seems to suggest that there was a time period of billions of years before there was any life at all.
Certainly on Earth, we know the universe is 13.77 billion years to a really quite extraordinary degree of accuracy. And we know that the solar system and planet Earth is about 4.5 billion years old. So what that means is 8 billion years before of the universe's history, when galaxies were forming. And then on Earth formed about 4.5 billion years ago. And about 4 billion years ago, give or take 100 million years or so, life formed on Earth. Now, there are plenty of other stars, plenty of other galaxies, plenty of other planets in the universe. We have only found life on our own planet, but we've been unable to look in any detail on the vast majority of planets. So it's possible that on other planets, around other stars, potentially in other galaxies, that life did emerge earlier than it did on Earth. We have no way of knowing whether Earth was the first planet that life emerged. But certainly in our neck of the cosmic woods, there were several billion years between the birth of the universe and the evolution of the first life on Earth.
So with regards to the first life forms, or the first living cell, the first bit of living material, how did that come about? Or is that possibly another question to which we don't have an answer?
First of all, we know what is required for life to operate. You need three things. So first of all, you need chemicals that are able to take part in chemical reactions that make copies of themselves. And those types of chemicals are referred to as autocatalytic chemicals, of which DNA is one. Each individual is a mechanism to make copies of their DNA. But there are much simpler chemicals that are able to get involved in autocatalytic reactions, which means they're able to make copies of themselves from other molecules and other material that's available, so other atoms and other molecules. So that's one thing. Life needs a replicator, an autocatalytic reaction. The second thing that life needs is a form of energy in which it's able to run its reactions. Now, our energy comes from eating other organic matter, plants and animals. So that's where we get our energy from. The very first life almost certainly got its energy from other chemicals and quite probably from volcanic activity on the early Earth. The third thing that you need to have in order to create a protocell, so the first type of cell that we would have had, is a cell membrane. And cell membranes are made from a type of fat called lipids. And lipids actually form really quite easily in water. So the three building blocks of life are replicating chemical, metabolism, and cell membranes all come about reasonably straightforwardly under the right conditions. What we don't quite understand at the moment is how all of those things came together into the first very simple cell. We know that it happened reasonably quickly because by 3.9 billion years ago, life appeared to be using the genetic DNA and the genetic code that we use now. But we suspect there was sort of simpler replicating molecules before DNA evolved. We know that a lot of the material for life to get going, including simple molecules like water, and also molecules made from carbon and hydrogen and nitrogen, we know that some of these are quite easily made elsewhere in the galaxy. And we know that because meteorites that have crashed to Earth have been examined, things like the Murchison meteorite, which is actually older than the solar system. And they contain large numbers of molecules, organic molecules, that are the building blocks of life. So we're pretty certain that a lot of the building blocks of life were formed in space, in either the death of earlier generations of stars, or also on dust grains and on meteors and possibly comets, that those were brought to Earth through collisions and through dust arriving in our atmosphere. Conditions were right on Earth, probably in either marine geothermal vents or on freshwater geothermal plains for life to get going. We haven't been able to create life yet in the laboratory, primitive life yet in the laboratory. But my suspicion is it's not going to be too long, hopefully in the next few decades. There's a lot of exciting research going on in that area. We know what had to happen. We don't know exactly what the conditions were for it to happen, but I think we're homing in on what those conditions are.
I just wanted to pick you up on a point that you've just made. If I were to play devil's advocate, as I do on the podcast, a retort to the idea that life came about from natural processes as opposed to some sort of supernatural intervention. People say, oh, well, if life can be created through natural processes, why can't scientists do it in a laboratory? And by all accounts, there have been a number of attempts to do so. What you seem to be saying is that you predict that perhaps within our lifetime, life will be created in a laboratory?
Certainly very simple forms of life. I don't believe it's beyond the realms of possibility. Life is just complicated chemistry. There's no doubt about that. And so the trick is finding out how you get those first three bits that I was talking about, a replicator, metabolism to run the energy to require life, and membranes, each of which we can create relatively easily, get them to come together and work together in terms of the first simple form of life. And we need to identify what the conditions are where that happened and what the conditions were like on the early Earth. We will become ever better at recreating those conditions in the laboratory. And once we create those conditions in the laboratory, there is no reason to expect that simple life will emerge. I don't believe there's any requirement or any need to invoke the supernatural here. Once life got going in terms of simple cells, those simple cells would have competed with one another. And much as evolution still works today, there would have been imperfect replication. And eventually we would have ended up with a genetic code built into DNA that all life on Earth uses today. This is one reason we know that all life must have descended from a universal common ancestor known as Luca, the last universal common ancestor. We know that used DNA, and our best estimates that lived about 3.9 billion years ago. And that evolved from a simpler form. Then for most of the history of life, life was single cells. It consisted of just individual cells that were competing with one another, but they would have got more efficient at what they did in terms of using resources. They would have diversified in terms of the environments they could live in. Eventually, they would learn to feed off one another, and you start to see the first very simple single-celled organisms living together in simple ecosystems, competing against one another, potentially hunting and using one another as resources to make copies of themselves. Then, probably about 1 billion years ago, the first multicellular organisms evolved, and they evolved from a type of cell called eukaryotes. They're much larger and much more structured than bacterial cells, and they continued to evolve, and complexity arose. And one of the drivers of complexities, again, would have been competition between individuals. And there was evolution, there was evolutionary pressures and natural selection in our branch of the tree of life to create more complex organisms, eventually resulting in you and me. But that took a long time. So multicellular life arose probably around 1 billion years ago, perhaps a little bit older. It really grew into its own in the Cambrian explosion about 20 to 560 million years ago. That's when multicellular life really diversed, and then it hasn't looked back since.
So you seem to be saying that life was single-celled organisms for quite some time. Is that right?
Absolutely, yeah. For the majority of time that life has been on Earth, it was single-celled organisms. Those single cells were getting more complicated. They were able to do more things, live in more environments. But we know that from looking at ancient rocks and looking for evidence of life going back. Some of the oldest fossils that we've got are getting close to 4 billion years old. There's fossil samples from the Pilbara in Australia at about 3.8 billion years, and also from Greenland of a similar age. And there's hints of early cells in those rocks, although, again, there is some debate about whether there could be non-living processes that could have generated those fossils. So there is certainly some debate about that, but certainly when we look at the evolution of life on Earth and what we see now, and we try and compare genomes, and so we compare the genetic code between species, and we run that back, it looks as if life relies on the DNA code that we use now was going by about 3.9 billion years ago.
And tell me about where consciousness comes into it. When did organisms become sentient?
That's a very good question, and it's still an area of active research. So the first kind of challenge that you have is to come up with a definition of consciousness or sentience. And the way that we measure sentience or consciousness, if you were to go into a hospital, is to look at the patterns in your brain waves. And we know that when you're thinking, and for example, as we are now, and chatting and holding a conversation and paying attention, that our brain waves look really quite different from when we're asleep or if we're in a coma and what have you. So they have a certain type of organizational structure when we're doing particular tasks. Now, that's how consciousness researchers have tried to characterize what consciousness looks like. It's a different question of where it comes from. Now, if you go and look at other organisms, including quite simple organisms, so invertebrates like things like octopus also have brainwaves, and remarkably, some of the brainwaves that they show are quite similar to ours. Now, octopus and humans, we shared a common ancestor over 500 million years ago, so a long time ago. And what biologists and consciousness researchers are starting to think about now is that consciousness lies on a continuum, or sentience lies on a continuum. We're certainly at the top end of that. We are conscious, we're aware of what we are doing. But another focus on consciousness research is all about the ability of organisms to experience the world around them. So they're able to detect what's going on and they're able to act in response to that. And certainly there's quite strong evidence that things like octopus have a fairly reasonable degree of consciousness and sentience. There is evidence that things like flies, even relatively simple organisms, flies, fruit flies, bees, are able to experience the world and are able to make decisions from that experience that they get. Now, that's not to say they're conscious in the way that we are. They're probably not, but they will have wisps of consciousness. So consciousness may have got going reasonably early.
So, following the appearance of consciousness, we then had a long period of evolution by natural selection, which has led us up to the situation where we are now, and we are human beings. So, just to fast forward, what does science tell us about when things will end? I've heard people mention the fact that the sun's going to run out of energy or something. So is the end of the world predictable according to scientific methods?
Yes. We know that the sun is probably about halfway through its life. It's about 4.5 billion years. And in another 4 billion years or so, it is going to run out of its hydrogen fuels. What it's doing is busy turning hydrogen into helium, into its helium core. The helium and other elements will eventually kind of get broken down and then recombine. The protons and neutrons will combine into some heavier elements. As the sun starts to die, and we know this from studying other stars in the night sky, it will go through a period of rapid expansions and rapid contractions. And those rapid expansions and contractions will extend well beyond Earth. They'll probably go out to where Jupiter is orbiting the sun from now. That will result in the end of any life that has remained on Earth. Now, it's entirely possible that life will have finished before then. There are some predictions that when the Earth was very young, it had an atmosphere that was low in oxygen but had much carbon dioxide. Life over the course of the last 4 billion years or so, carbon dioxide levels have been falling. Yes, we're pushing them up at the moment. Human activity has increased them a little bit, but the general trend is for a decline in levels of carbon dioxide. There is some estimates that by about 1 billion years' time, that life, i.e. plants through photosynthesis, would have exhausted all of the CO2. Once they're unable to photosynthesize and unable to grow, then there will be no oxygen created. And once oxygen's no longer being created and gets used up, then life, apart from perhaps very simple bacteria, is expected to die. Life may find new ways of exploiting new resources. Volcanic activity will push some carbon dioxide up into the atmosphere at times. So the 1 billion years is kind of only an approximate estimate. But yes, life isn't going to go on forever, and humans will face the fate of all species, which is extinction, unless we work a way of getting off this planet and colonizing other planets. But our ability to do that at the moment is very, very limited.
Going back to something that you said earlier as well, you're not ruling out the possibility that life exists in other solar systems.
Absolutely. In fact, it may exist on moons around other planets within our solar system. What biologists know or strongly suspect is that you require liquid water for life to exist. And certainly some of the moons of Saturn and Jupiter do have liquid water under thick layers of ice. some of those moons also have volcanic activity. So it's not beyond the realms of possibility that life has evolved on those planets, but we're unable to see it because we can't get through the thick ice to investigate the water at the moment. Whether we'll be able to do that at some point in the future, who knows? We've looked for evidence of other planets that are a bit like Earth in the fact that they're rocky and that they orbit their planets at a distance where liquid water could exist. Certainly Earth-like planets, a distance from their star where water could exist as a liquid, have been discovered. There's no evidence for any life on those yet, but we've only explored a really, really tiny corner of our universe. We're also listening out for life. SETI, the Search for Extraterrestrial Intelligence, is an ear to space, listening out for signs of life like radio waves that might be created by other civilizations. However, the universe is so large, we've only been broadcasting radio signals for a little over a century. That means that if there was an extraterrestrial civilization on another planet, they would have to be really close by on galactic terms for them to have heard us and then to have replied. So although we're listening, and the fact that we are yet to find conclusive evidence of life on another planet, it certainly doesn't mean that life doesn't evolve elsewhere. We have no idea whether it's common or whether it's rare, and we have no idea the frequency with which it evolved to become intelligent life. But given it can happen on Earth, and we've got no suspicion to suspect that Earth is extraordinarily unusual, it strikes me that life probably does evolve fairly frequently. Even if it's only evolving, say, once in our galaxy, the Milky Way, there are a vast number of galaxies that we can see across the night sky. Even if it evolved on average only once in each galaxy, we would still have 100 trillion plus planets where life has evolved. What I think is really difficult for people to get their heads around is quite how staggeringly vast the universe is. We have explored an extraordinarily tiny fraction of it. So to rule out that life does not exist widely, is a very foolhardy thing to do. We just don't know at the moment. But Earth doesn't look as if it's particularly unusual.
So if you were a betting man, would you put money on there being other life forms in other parts of the universe?
100%, yeah. I think that our universe clearly has the right conditions for life to begin and evolve. Otherwise, we wouldn't be here having this conversation. And given it's happened once, and given the universe is so large, I don't understand why it wouldn't. Where's it happened? It's happened on Earth, not a particularly unusual sized rocky planet, averaging an average sized star, in the suburban part of an average sized galaxy, which is one of a staggeringly large number of galaxies in the observable universe. We're certainly not in the center of the universe. It looks like, we have evolved, we have arisen around an average star in an average galaxy. So yes, I'm pretty confident that life exists elsewhere in the universe and it has evolved independently. We are yet to find it, so I can't prove that. But you asked me if I'm a betting man, I'm not. But if I was, I'd put quite a big wager on it. Whether we find it in our lifetime is a completely different question.
So we've talked about the end of the universe, or certainly the end of our solar system, the end of the Earth. What about separate life forms? Presumably, the position is going to be that when consciousness ends and the brain dies, there is nothing at all that lives on apart from, I guess, the matter that we're made of. Is that something that you would suggest is the case? Death is the end. There's no afterlife.
I'm made from matter. I'm made from quarks and electrons. Those have combined. The story by which they're combined to create me, I think, is amazing. It's awe-inspiring. I think it's absolutely staggering that science has been able to piece so much of that story together. Of course, there are bits that science hasn't got the answers to yet, but with each year it finds out a little bit more. There is no evidence that the brain is supernatural. I believe that consciousness is a consequence of being me. When I die, along with my heart stopping working and my other organs stopping working, my brain will stop working and consciousness will die. That will be it. The molecules, the atoms that I'm made up of will be commandeered by other forms of life, or some of them will. So whether those are worms chewing through my rotting corpse or insects feeding on me, some of the molecules, some of the atoms that I've been made of will appear in other life forms, but my consciousness won't, and that's it. But that doesn't bother me. It doesn't concern me. I think it means that whilst we're here on Earth, we should work to make our lives useful and good and enjoyable.
I played devil's advocate a little bit earlier when I talked about scientists being unable as yet to create anything resembling life in a laboratory. And I'll play devil's advocate a little bit more because that's what the podcast is all about. How would you respond to somebody who would say something like this? Yeah, you mentioned earlier Luca, and Luca being a common ancestor of every single life form that has ever existed. And you said earlier that humans and octopuses, is it octopuses or octopi? We share a common ancestor with octopuses. We share a common ancestor with the flowers in the garden, I guess.
Yeah.
So how would you respond to somebody who would say to you, come on, Tim, the fact that I'm related to my dog, my cat is, a very distant cousin, that's just preposterous. Intuitively, it just sounds ridiculous.
So if I was to ask you, do you think you share any DNA? So DNA is the molecule of life. It's a self-assembly instruction manual for a body. Do you think you share any DNA with your parents?
Well, obviously, yes.
Yeah, so you get 50% from your dad and 50% from your mum. And what about your 4 grandparents? Do you think you get any DNA from them?
Yes.
Yeah, so from each of those 4, you get 25%, 25%, 25%. Great-grandparents, it goes back a little bit further. And you keep going back further and further in time, and you'll share less and less DNA with each of your ancestors. What geneticists can do is we can go and read your DNA and my DNA, and we can work out how closely we're related. But we can also go and read the DNA of other species. So we know that we share 99.9% of our DNA with chimpanzees. We know that we share about 30%, I think that's right, with bananas. And so we can read it in the DNA. We can look and we can see that there are some genes that are highly conserved, is the word that scientists use, across life. All life uses a few enzymes, a few key genes. There are other genes that are unique to dogs and others that are unique to humans. And then you and I will have different variants of the same genes that make us different. That mean we look different, that we probably have different color eyes and different color hair. We certainly have different voices, will be different heights. And so it's evolution by natural selection operating to weed out poor DNA, DNA that doesn't provide an advantage, and select the DNA that provides it. That's a fact as true as gravity or electromagnetism. It's a process that operates not just on Earth, but will operate throughout the universe for any living organisms. And the fact that we can work out how closely not only you're related to your parents and your grandparents, but to other species is what's allowed us to put together the tree of life. And I think that anyone who's still arguing that in some way we are not related to other forms of life on this planet is delusional and really hasn't read or has failed to understand the evidence.
What about those who would say, well, yes, we've got similar DNA to other life forms because a supernatural force used the same template when creating these different forms of animals? Is that something which is easily debunked?
Well, I mean, there's no evidence for that yet. There is evidence from DNA mutating. We've been able to demonstrate how DNA mutates, why it mutates, and what the consequences of those mutations are. So we have a really good understanding of the mechanisms via which evolution can lead to different individuals within a population of a species, but also how different populations of the same species diverge from one another over time, and also how speciation occurs. Now, we've got evidence for that. To come and say, oh, well, there's some supernatural being who always uses the same template, That seems to be a more complicated argument. And I will always go with Occam's razor that says we should always take the most straightforward and the simplest argument. And Occam's razor, I think, is really strongly pointing to the fact that we all are descended from Luca, the last universal common ancestor. It's taken a very long time for the diversity of life that we see around us now to evolve, but it has evolved. And there is absolutely no evidence for some supernatural being with its own template that just decides it's going to create millions of different species and throw them onto the planet.
Okay, so you seem to be saying with virtually, if not 100% certainty on this, that evolution, and specifically macroevolution, where one species can change into another, that is, as far as you're concerned, established fact, and no one can reasonably disagree with it.
It is fact. There is so much evidence that evolution happens. We know the process by which it happens. We know the mechanisms that underlie those processes, and we know the patterns that it generates. There have been endless cases where people have set up experiments, where they've evolved things in the laboratory, where they've seen that evolution occur, where we understand why some organisms that are reasonably closely related are unable to produce viable offspring that can breed themselves. This is all well worked out. It's all well understood. Arguments that claim it's just a theory or it's not supported, is really kind of a last-ditch attempt to clutch at straws because people are frightened or fail to understand it. No, evolution is as real as gravity. It's as real as electromagnetism and the other fundamental forces.
And that includes macroevolution as well, because you mentioned in the laboratory that scientists have observed evolution, but presumably it evolves into another version of that species.
So macroevolution is just microevolution, the sort of stuff that we can measure in the laboratory writ large. Remember, we've got 4 billion years of time we're playing with, and it takes a few million years for bird species to diverge such that they're unable to reproduce together. So macroevolution isn't anything special. It's just microevolution playing out over very long time periods with the opportunities for mutations to occur, which means there's genetic divergence between populations that are not sharing their DNA between them. Yeah. So yes, absolutely, completely agree.
And have we found a missing link, perhaps an organism that shares features with the species it was prior and the one it's in the process of turning into?
When people talk about missing links, they used to say, well, what was the species that we shared a common ancestor with chimpanzees? And there are 3 fossil candidates that people have found from the right time period that suggest those are the cases. We then know that the first species on our branch of the tree of life that's not on the same branch as chimpanzees are the Australopithecines. So they were a group of organisms that lived about 3 million years or so ago. The Australopithecines evolved into Homo habilis, which was the first species in the Homo genus, which is the group of species to which we belong. We know that they use very simple hand axes. They use them a lot. Homo habilis went extinct and evolved into Homo erectus. Lots of fossils exist for Homo erectus. It was an unbelievably successful species that looked similar to us, but had a smaller brain and was probably a bit more carnivorous than we were. That spread out of Africa into Asia and into Europe, where, again, it evolved into different subspecies or different species. Homo erectus also evolved into Neanderthals and into Denisovan man in Asia and into Homo sapiens, so us in Africa. We then know that Neanderthals had culture, they had language, they buried their dead, they produced art. There's jewelry has been found from Denisovans. We know less about the Denisovans than we know about the Neanderthals. And we know that humans, so Homo sapiens and Neanderthals and Denisovans, all were able to breed together and did breed together because we've been able to find in some populations a high proportion of people actually having small amounts of Neanderthal DNA and other populations having small amounts of Denisovan DNA. So we understand this well. It's true that the fossil record, the further you go back, becomes sparse, and so not everything gets fossilized. Given the human population that we've got now, only a few tens of us could expect to become fossils, despite there being 8 billion of us on the planet. Most organisms don't fossilize, so the fossil record is sparse, and so that means there will be some past species out there that didn't fossilize. The fact that we haven't found them doesn't mean they didn't exist. It's just that we don't have a good record of every single species that exists going back in time because the fossil record is indeed sparse.
What about the suggestion that all of this talk about the Big Bang and Luca and evolution from single-celled organisms and so on? Common counter-argument, a common thing said by people who hold more supernatural beliefs about why we are here. How would you respond to the suggestion that it's not science because it's not observable, can't reproduce it and observe it, and because it's not science, it's speculation because you can't run an experiment to prove that the Big Bang happened? So how would you respond to suggestions that speculating about what happened billions of years ago is not really science?
Well, so the scientific method is an incredibly powerful tool. The way that it works is you make some observations and you then look at those observations and you try to make sense of those observations. And if you can do an experiment to test that parts of those observations or bits of those observations, then you do. Sometimes to make sense of those observations, you may well construct a mathematical model, and then you can use those mathematical models to make some specific predictions that you can then go and test. Now, probably one of the most remarkable predictions that scientists have made of something that they couldn't see was they made a prediction about the existence of a particle called the Higgs boson. And the Higgs boson was predicted in something called the Standard Model. And the Standard Model is a model in physics of fundamental particles and how those fundamental particles interact. And it unifies the electromagnetism with the weak and the strong nuclear forces. And that model, it's a very elegant model, but it's mathematically quite complicated, quite challenging. The model would only work if there was something called the Higgs boson that gives fundamental particles, with the exception of the photon, mass. And so Higgs boson was predicted, and the Large Hadron Collider at CERN under Switzerland, the world's largest machine, was built, and that was built to look for the Higgs boson. The way to look at it was by accelerating tiny particles to very close to the speed of light and colliding them with one another, and then looking to see what those collisions generated in terms of particles. Those collisions were examined through very large, complicated detectors. And the Higgs boson was where it was predicted to be. So science was able to say, we know that this must exist if our theory is correct. So let's go and look for it. And we found it. Very similarly, theories about the Big Bang make some specific predictions about things like the cosmic microwave background. When people went and looked for it, it was there. You can use models not necessarily just to say, okay, we need to create new universes to prove that it can happen. You can actually make some predictions from models about signatures of events that happened in the past. And when you go and look for those signatures of events and you find them, that's evidence that supports the hypothesis that you're testing. And when you generate multiple streams of evidence from different observations, that provides good evidence and increasing evidence that your model is real. And eventually, I think that science collects enough data on these things that it becomes fact. And that's kind of coming back to what we said with evolution. We can write down mathematical models that predict aspects of evolution. We can run those models and we can see that they work really quite well. Ditto for evidence for the Big Bang. So although we can't reproduce the Big Bang, we can't do that experiment, we can't create our own universes. It's something I'd love to be able to do, by the way, but then people would probably claim that I've created God in my own image because I've created universes in which life could evolve. So you can't win with these people some of the time. But I think science is a very, very powerful tool. It's arguably humanity's greatest invention. It's told us so much about the world. If we didn't have science, we'd be a bunch of philosophers sat outside trying to make head or tail of the world, but mainly just coming up with myths.
So what you seem to be saying is that although we can't observe the Big Bang, recreate it or whatever, if there was a Big Bang and if there was macroevolution, there would be things that we could observe in the present day which provide quite a lot of support for those ideas.
Exactly. That's exactly right.
Yeah. Another thing to ask you about is that believers will often invoke what is called the anthropic principle. And that's the idea that, and apologies if I'm patronizing you here by explaining it, but I'm doing it for listeners, if anything else. That's the idea that the earth is so fine-tuned for life, and in particular human life, that there has to have been an intelligent designer behind it all. Now, the obvious counter-argument to that is that there are many things that seem to have an imperfect design. The light source of the earth gives us cancer if we stay out too long in it. I guess you could also say that with a universe that is so vast, there is bound to be somewhere mathematically where the conditions are right for life to exist and to thrive.
I'd actually give a slightly different answer. Intelligent life could only exist in a universe that has the properties for it to exist. So if our universe didn't have the right fundamental forces, gravity, weakened nuclear forces, electromagnetism that took the right strength for all the things that had to happen for us to exist, we couldn't exist in a universe that wasn't right for life. We could only exist in a universe that has the right properties for life. The whole argument that the universe is just right for us to exist is some evidence for a higher power having built it. It makes no sense at all to me. We can only exist in a universe that has the right properties for life to exist. I just don't understand it. We can't exist in a universe that isn't right for us to exist. So the fact we exist means we must be in a universe that has the right properties. A different question that perhaps is more important is how likely is it that universes that arise that have the four fundamental forces that are required for life and have them at the right strength to occur? And we don't know the answer to that question. What we do know from models is that if gravity was, say, just a little bit stronger or electromagnetism was a bit weaker, then life probably couldn't exist. So one of the questions that science doesn't have the answers to at the moment is why do we have four fundamental forces? And why do those four forces take the strengths that they do? I'm very glad that they do take those strengths, and we know that they had to have those strengths for us to exist, but we don't know how many universes there are out there or have been that have different numbers of forces or the same forces at different strengths.
So I'm going to move on to the world of what is called creation science, which you're probably of the opinion is an oxymoron, maybe.
I think you've worked out where I sit on this one.
In America, this is still a very widespread belief that the Earth is 6,000 years old and humans have been like we are today ever since the beginning of life. Are you saying there's absolutely no scientific validity to that belief whatsoever?
I have to admit that I've never really studied it in a huge amount of detail. It's fringe science, right? It's clearly fringe science. What I will say is I'm not on a mission to try and persuade people to change their mind, because I know that in many respects that's futile. So I'm not on a mission to convert people to my form of atheism. All I would say is engage with proper science. It's absolutely amazing. We can all be scientists. We all actually use the scientific method in everything we do. If we want to solve a problem, we'll think, well, let me give that a go. If it doesn't work, you go back to the drawing board and you come up with an idea, having learned from your past mistakes. That's a form of hypothesis, and you're testing a hypothesis. So we're all naturally scientists at heart, and we can all be scientists. And my message would be is science is fantastic. It's amazing. It has told us so much about nature, so much about the universe. And the story that it tells us is just remarkable, and it's awe-inspiring, and it's fantastic. So I would say don't close your mind to the idea of science, and don't come up with this sort of pseudo-twaddle creationism science, because it's not based on any evidence. It's not true science.
And I did say to a creationist, in fact, a young earth creationist quite recently, if this is really true, that the Earth is 6,000 years old, if it's really true that we didn't evolve from simpler life forms and human beings from day one appeared pretty much as they do now, if that were true, that would be Nobel Prize winning stuff, wouldn't it? If you could prove that we've been wrong all of this time, you'd make a name for yourself if you were able to scientifically prove a young Earth and the lack of evolution. Would that be something that you would agree with me on?
Yeah, no, I would completely agree with you. If you were able to overturn the huge amounts of scientific knowledge that we've got about the age of the universe, the age of the Earth, evolution, all of those things, and you were able to come up with another theory that you were able to find support for that's as strong as the support we've got for a 4.5 billion year old solar system and that life evolved 3.9 billion years ago, you'd need some very, very compelling evidence. If that evidence is there, you would be able to change the mind of true scientists. They'd say, yeah, we did get it wrong, and there's an alternative theory that's extraordinarily well supported. But at the moment, that evidence clearly doesn't exist. It's fine to create hypotheses that are non-mainstream. Darwin did it with evolution. People take a long time to accept, but the way that you deal with it is say, okay, well, that's a hypothesis. What evidence can we get to support that hypothesis? Then you look at that evidence and you look at the evidence for competing hypotheses and you go along with the hypothesis that is best supported. Now, at the moment, the Earth being 6,000 years old, there's absolutely no evidence for it at all. It's bonkers, quite frankly. You asked me if I was a betting man earlier. I'm not going to bet on them winning a Nobel Prize anytime soon.
Okay. You mentioned evidence, and certainly if you go onto the websites of organisations such as Answers in Genesis, who you may have heard of, and Creation Ministries International is another organisation I'm familiar with. They do claim to have evidence and make a scientific, perhaps you'd say pseudo-scientific justification for a 6,000-year-old Earth and the absence of macroevolution. But I think it's quite telling, isn't it, that you will never get a secular scientist saying, hang on, we've been wrong all of this time about the age of the Earth. Those young Earth creationists have had it right all along. The people who come out with this stuff exclusively are the people who believe in the supernatural versions of how the Earth and the human race came into existence. And I think that, for me, the fact that no one has substantiated young Earth creationist claims from a secular viewpoint, it's people who have the belief in the first place and then try to find evidence to fit what they believe.
I think that's absolutely right. And thank you for going to those corners of the internet so that I don't have to.
So, to finish up then, you've very articulately explained the origins of the universe and the origins of life without a supernatural power. And this perhaps goes back to something that you touched on earlier. If there is no supernatural power, there's no God to answer to, then what's the point of life?
So from a purely biological reason, it goes back to sort of something we talked about earlier. My genes will go on if my children breed. I've got 3 children, and if they go on to have children themselves, my genes will spread. That's what evolution is all about. Now, I know that people say, well, that's a very reductionist view of the world. I think the question you're asking about is, if you're secular, if you're an atheist, can your life have a cause? Can it have reason? Of course it can. I mean, we're conscious, sentient beings. We're aware of the world around us. We're also social beings. So we have evolved in a social setting where we have lived in groups with other people. And evolution has molded us to help our family members, to look after our young, to also help other members within our group. And being able to help other members in our group and to support people clearly has meaning. Now, I decided from a relatively young age, sort of 20-ish, that I wanted to try and understand what science could tell us about why we existed. And ultimately, it culminated in the book that, we've been sort of discussing earlier today. And the content of much of this podcast is in that book, if people are interested in reading it. I don't believe there's any evidence for supernatural being. I don't think we need a supernatural being to explain our existence. I think science has come a long way in doing that. It hasn't got all the answers, but it's got many of them. And I think we can give our lives meaning, and I think we can live good lives. And I think one of the reasons we do that is because of our ancestors' past of living in groups. People who showed antisocial behavior or unacceptable behavior in a group would have been kicked out or possibly punished, even with death in some cases. We know that occurred. Our society, our social norms all come from what we've evolved to be. And we can live good lives, of course we can. And that's how you fit in society. If you're antisocial, you're not going to fit into society, and you're probably not going to live a life that you enjoy or a life that your colleagues and your friends and your family members see as worthwhile.
Excellent. That seems like a fitting place to end, I think. So thank you very much for your time this morning. Good luck with the book. It's called The Universal History of Us, and it's available presumably in all of the usual places, Amazon, etc.
It is indeed, and I do hope that readers enjoy it. It's written to be accessible to anyone. It sort of champions science. And thank you very much for having me. I've really enjoyed talking, Rob. It's been great.
It's been a pleasure. And that's a wrap for this episode of the UnShaw Podcast. We've covered a lot today, but before we go, I'd like to indulge in the time-honoured radio tradition of celebrating notable birthdays. This Sunday, let's raise a glass to Luca, yes, the last universal common ancestor who emerged roughly 3.5 billion years ago and is the great-grandparent 1 trillion times removed of all life on Earth, including everyone listening to and involved in the production of this podcast. Thankfully, Luca was able to reproduce, and Luca's descendants became masters of survival, evolving to harness the resources needed to sustain life. Fast forward to today, and when we pass on, the matter in our bodies will continue that legacy, feeding into the next generation of Luca's descendants. Now, how's that for perspective? But in the interest of balance, I've got something special lined up for next time. I'll be talking to a young Earth creationist, but not your typical keyboard warrior. Nick Cowan holds a degree in natural sciences from Cambridge, spent decades as the head of science at one of the UK's top schools, and is a prominent speaker for the Truth in Science movement. Some may know him from his YouTube debate with none other than Richard Dawkins, just racked up over 400,000 views. So, whether you're firmly in the evolution camp or curious about the other side, you won't want to miss it. Until then, be kind, stay curious, and I'll catch you next time.